Hello, Year 7. I'm going to be running through a revision document for you on a PowerPoint today, which will really help with your upcoming tests. So make some notes as you go through. I would do that just on a lined piece of paper or a blank piece of paper, and it will just give you a really solid foundation of everything that we've done with the ping pong launcher. So what do we know about softwoods and hardwoods? Hopefully you've learned quite a bit through the project, but as an overview, we will just talk through softwoods. So most are evergreen. They are also cone bearing, so carnivorous with thin needles. They are good because they are cheaper and they are also still strong. They grow a lot faster. They normally reach full maturity in 30 years. That means that they're a bit cheaper for commercial use. And the structure of them, they're made up of tube-like cells. So that is why you'll often find that they're a bit more lightweight when you pick them up. Hardwoods, again, they get their name because of their cellular structure, not because they're just hard to cut. They are generally quite hard and durable, but there are exceptions. Can you think of the exception to the rule? That's balsa wood. They're generally slower growing. They might take up to 100, 120 years to reach full maturity, and that's why they're really expensive to buy. They are normally known as deciduous trees, which means that they lose their leaves in winter. So what material did we make the body of the launcher from? Have a quick think. Hopefully you know the answer. That's correct, it's pine. Is pine a softwood or a hardwood? What do you think? Softwood, correct. And give 3 reasons why pine is a good choice of material for this project. So have a quick think here. It'd be really good actually if you wrote down 3 points. I'll give you a second to do that, or your teacher can pause the video. They're easy, really easy to cut and shape, quite cheap because they are much faster growing than hardwoods, and also looks nice. So you do get a really nice, attractive grain on the pine. Are there any disadvantages to pine? Can anybody think of anything that maybe happened to their project? That's correct. It can split quite easily. So if you've dropped it out of the vise, you'll certainly know about this. Okay, tools and equipment recognition. Have a think, what are these 2 saws called? I want you just to really quickly sketch them out. They don't have to be in 3D, it could be a very simple 2D sketch. And then put a name next to both of those saws. I'm sure on your table or your next door neighbour will be able to help you with your answer if you're not quite sure. So this is a coping saw at the top. It's got a U-shaped frame. I often call it a C-shaped frame to help you remember it's coping, a C for coping saw. But it's a U-shaped frame officially, and it's got a thin blade held in tension. You can angle the blade. It's really good for cutting curves or internal shapes. If the blade breaks, we can easily replace it. You'd call it an adjustable saw. And the blade is very thin, which is sometimes why it snaps, because it's held in tension. If it's being forced around a corner that it doesn't really want to go round. And then we've also got a tenon saw. So a tenon saw falls under the family of back saws. It's got zigzag teeth so that the saw doesn't get stuck in the wood when it's cutting. And you'll see that this one here has a brass back, and that just provides stability. The blade is also then being held in place. It's got really hard teeth on it. It means it's really good for cutting wood accurately and with precision. Now, can you name this tool? Can you think where we used it in our project? So jot that down. What is it for? Can you give me a brief description of what you would use this for? So this is a rasp. And in woodworking, rasps are just used for wasting tools, okay? So they're just for removing wood, normally from curved surfaces, really quickly. It's not about finishing the wood. It's not about sanding the wood. It's just about wasting away and sort of shaping the wood. So you probably, hopefully, use this to shape your handle and make it more ergonomic. Now, I'd like you to turn to this page in your booklet. I think a lot of you, I know in my class, did it really, really well, but it's always good just to double check that you've got enough detail in there. So if you can open up this page in your booklet, if you've got that with you today, and we're just going to very quickly run through what they all are and what their purpose is. So the first one we've sort of just done, that is the tenon saw. A dowel. We often use dowels to connect with joints. So you'll often find things like a dowel reinforced butt joint, for example. We use dowels obviously just to ensure that we could use the elastic bands, make sure they had somewhere to actually be positioned on there. The next one, the third one along, we've just run through that. That's the coping saw. And then we've got the fourth one along, and this one's quite a tricky one to spell. So I'm going to show you how you spell that, and it's called a Forstner. And we use this to drill out, hopefully you remember, the large diameter holes. So it's really good for cutting large diameter clean holes in wood, and it has a center point just to help with precision. And a bonus mark for you, can you remember how big the holes were that we drilled? I think it was 41 millimeters. Okay, the next one along is pillar drill. Okay, and the pillar drill is mounted on the floor. It can be used on a wide range of materials, and often you'd actually slow down the gearing system if you're drilling into metal. So you'll see that in DT4 the drill in there goes a little bit more slowly than the one in DT5 and DT6. The head can be lowered vertically, plunges into the material by means of a hand lever, and the table, or we sometimes call it the platform, it can be adjusted for varying sizes and thicknesses of materials. You can also angle it as well sometimes if you're using things like jigs. The great thing about the pillar drill is you can get a little bit more power, a little bit more force by just grabbing the handle. So I guess you would probably use the word leverage or leverage here. You're going to get increased leverage compared to maybe using something like a hand drill. The next one along, hopefully remember this one. This one we used right at the start of the project, and this is a tri-square. Now a tri-square is a really excellent bit of kit. We try and use as much as we can in DT to be accurate with our marking out. And it's for marking out lines perpendicular to an edge and for checking 90-degree right angles. You normally use this with wood or plastic. There's an engineer square for metal. Now a little bit on ergonomics. So we talked about this, you did a homework on ergonomics where you chose hopefully a household object that was ergonomic. But ergonomics is the study of people in relation to their working environment. So that means designing products in a way which makes them really easy to use and also safe, and hopefully as accessible as possible. Now, ergonomics also means ease of use. So the designer is going to carefully think through how people are going to engage with a product. Ergonomics can actually also be about things like user interfaces as well. And designers are going to try and make controls super easy, super clear to use. So for example, really large, a volume control on a stereo, that's a really good idea if you're sort of wanting to finely adjust the volume. Colours and symbols also come under things like ergonomics, and dials, displays in cars, making sure that it's in your line of sight. Safety. We talked a little bit about this, so I'm not sure whether you remember what this sign is, but that is the BSI, so that's the British Standards kite mark, and that's just used to kind of make sure products are safe for use and they've met regulations. Now, there's lots of laws and regulations, and actually British standards are some of the best in the world. But safety sort of falls under ergonomics. So it's the designer's responsibility to make sure that things are safe that they design, not only maybe easy to pick up, easy to use, easy to hold. So things even like sharp edges, finger traps, you'll notice in DT, for example, the on-off buttons, the power buttons, it's much easier to hit the red off button than it is to turn the green on button for safety. Anthropometrics, this is all about the data, and the data drives the designing. So you'll see there's a little graph there, and it shows you the 50th percentile average. You know, it's going to be the most frequent, most common data there. And it's interesting designing, because actually designers don't really ever account for the 5th and 95th percentile, because they are so extreme, their measurements are so extreme. So you'll notice that, you know, even the table that you're sat at today, the chair you're sat at, it is really designed for the 50th percentile person. Now, it also means in sort of actually collecting measurements. You might remember we sort of measured our hands so that we could actually design an ergonomic and correct anthropometric handle. So it's all about making sure designs fit the user properly, and anthropometric data is always developing, and it's actually different from country to country as well. Now, what I want you to do quickly is have a look at this cordless drill and think about what makes it easy to use, what makes it comfortable to use, and try to identify at least 5 ergonomic features of the cordless drill. So have a go at writing that down now, give it a title, cordless drill, ergonomics, and think of 5 features. Your teacher might want to pause the video. So the ones that I came up with, it's got a really good centre of gravity that allows it to be really easily placed on a flat surface. It's weighted at the base. It's got a TPE, thermoplastic elastomer overmolding for the grip. So the black bit there is the TPE overmolding. It's got a bit of a texture on the chuck. The chuck is where you adjust, you know, putting in or taking out drill bits, and it just means that it's slightly easier to put the drill bit in. It's got a really large on button in the position of your index finger, your trigger finger. The diameter of the middle section, I would say, is suited to most adult hands. Probably some of you found actually holding the cordless drill quite tricky, because it is designed really with sort of male hands in mind. It's also got really curved, rounded shapes for safety. And you've also got a really easy to change battery at the base if it's held in one hand. So you can hold the drill in one hand and squeeze in the 2 sides to release the battery. Now, quality control, what does this mean? So quality control is a check that's made to ensure that a component meets the specification a manufacturer has set. So for example, that might be the correct size, the correct shape or colour. And I want you to think, what did you check as you made the ping pong launcher? Now, if you were in my class, you had to pass Mrs. Crawford's quality control checks. And mostly I was looking at visual checks, making sure that the holes were positioned in the right place, and hopefully that you'd used your template correctly for your handle design. We also checked measurements, made sure that things like that front block fitted really neatly, where you'd cut the notch out in that first or second lesson. So quality control, just make a note of what that is. It's something that you will always come back to in every project, whether you realise you're doing it or not. You'll often sort of run visual checks on your product. Now, CAD, what does CAD mean? So you'll see here there's 2 examples of CAD, one that looks a little bit less finished than the other. And CAD stands for what? So just have a go at writing this down. Computer aided design. So CAD, sometimes it will look really photorealistic, and you know, you'll be fooled into thinking it's actually the real product, but CAD you can generate really incredible renderings to make things look realistic, but that still falls under CAD, okay, so computer aided design. Now, what I want you to think about are three reasons, three advantages of CAD. So looking at that picture there, why might it be useful to just do that on CAD rather than maybe try and make this speaker in reality? So think of three reasons. I want you to jot those down now, please. Okay, you might want to pause the video. So 3 reasons: easy, quick to edit or modify the drawings, really accurate drawings. You can often see around an object 360 degrees, particularly if you're using programs such as Inventor. You can join components together, so you actually get to sort of actually do things like hinge. You can move parts as well. You can save and edit your ideas, which makes it really easy and cheap to modify your design, particularly if you get things like user feedback. You also can send your files abroad or to people in different parts of the country. You can buy in standard components, so it means it's a bit faster to buy in a standard M6 screw rather than trying to build that yourself. And it can often be more accurate than hand-drawn design, so it reduces human error and looks better. Now, CAM, you can see a couple of videos here of CAM machines. So CAM, similar to CAD, first 2 words are the same. So what do you think it is? It's computer aided manufacture. So this is basically about the making of the CAD files that you've created. Now, the machines used in the CAM process, they are always CNC, so computer numerically controlled. And that basically means the CAD-CAM program, it works out the necessary movements of the tool head of the machine, sends the data to the machine in the form of numbers. And the onboard processor interprets the numbers, controls the movement of the tool head. So CNC machines, or CAM, that includes things like lathes, drilling machines, laser cutters and vinyl sticker machines. And some of you might have used the laser cutter previously. We've also got a CNC lathe as well, which is really useful. Sorry, CNC router. Now, laser cutting. What are the advantages of laser cutting, do you think? So, highly accurate, capable of achieving fine detail, can be fully automated, so it could work all day long if we wanted it to. It's really easy to cut identical components, but on the flip side, really expensive. Lasers can damage your eyes, and it's not very good on things like mirrored surfaces. So you might want to just jot down a few points there about laser cutting. Now, a design specification. What is it? So you may remember you did this for a homework to come up with 10 points. And this is just a detailed document, and it basically is setting out exactly what a product or a process should do. It's really important to have a design specification, because otherwise you're clutching at straws. You don't really know what you're meant to be doing. So your design spec, it might include things like dimensions, sizes, maybe some environmental factors, ergonomic factors or features, and maybe even the way it needs to look, so the aesthetics of it. So what did your ping pong launcher need to do? I want you to just jot down 3 points of what it needed to do. So things that I came up with, it definitely needed to hold 2 ping pongs. It needed to launch 1 ping pong ball a distance of 2 meters, be made from pine, which is a softwood, and also have an ergonomically designed and manufactured handle for your hand size. So just jot down what a design spec is and maybe a couple of points there. And then one of your final tasks is to write a 10-point plan of manufacture. So I want you to use page 7 in your booklet to help here. So the first 3 are done below. You might actually want to split number 3 into 2. So you could actually have, drawing out and making the handle as one stage, and maybe actually cutting out the handle out of the pine body a second further stage. So have a think about that. What I'd also like you to do, as well as write down the main 10 stages, is also just do some mini sketches to kind of try and help explain this. So you can see I've grabbed 3 images from the booklet that are on page 7 and 8, and these images are quite good at just sort of representing, just showing what's going on. Now you might want to draw yours in 2D, absolutely fine, as long as you're visually representing what you are writing. And then the final task of today's lesson is a drawing task. So I would like you to have a go at sketching out that block below in 3D with the holes in. And then I want you to try and sketch out the ping pong launcher in either 2D or 3D. And as an extension task, try and label up the parts. So you may remember you had a go at coming up with 4 handle designs for your for one of your homeworks, and I want you to actually now try and draw your final design that you came up with in 3D. So there's going to be a couple of things to help you with that, but hopefully you'll be able to improve some of your sketching skills. It's a really tricky object to draw, so if you come a bit unstuck with it, don't worry, just break it down into manageable chunks. So we'll be doing things like crating in the object, making sure initially it's almost like turning a rectangle slightly on an angle, so that should really help. The holes are always notoriously quite tricky to do, but have a go first of all at doing that slightly more simple basic block shape, and then move on to doing the ping pong launcher in 2D or 3D. You might even quite like to kind of trace over the image just to get a sense of what it should look like before you do your own drawing. Okay, good luck with the test. I really think that hopefully this has covered everything off that you need to know about. So you can always re-watch this through if you didn't catch everything in the lesson. And just make sure you've got some notes. It's always a really good habit to get into at school, just making a few basic notes, because a lot of this stuff that we're covering now, you'll revisit it, and whether you carry on and do GCSE, all of this knowledge that we are covering now, we do also at GCSE and A level. Okay, good luck, boys. Take care.